Thanks very much, Darlene. I'm going to try to speak without a microphone. If anybody at the back finds I'm too quiet, please let me know and I will put the stupid thing on, but I find generally I don't need it. I'll yell at people at the front, and those at the back should be fine. I will say before I start, I did have a question earlier, about half an hour ago. Somebody said, what are you going to be talking about? And I mentioned sort of, drugs, industrial surfactants, those sorts of things, and they looked a little disappointed. They were expecting arsenic and those, more common compounds or contaminants of concern. If there are people here who were expecting metals or nutrients or stuff like that, please don't hesitate to go to another session if you feel the need. I'm not being facetious. Seriously, I won't be offended if you were expecting something else. I am talking about, as I mentioned, pharmaceutical compounds, industrial surfactants, what else? Plasticizers, synthetic fragrances, those sorts of things. And obviously the sorts of concerns that we have around those compounds in aquatic ecosystems. So that being said, I'll give you a quick outline here. Initially, I'll start with some background information, some terminology, such that we're all on the same page. I'll give you an idea of what Alberta Environment has been doing over the past almost 10 years now. That's kind of scary. And then I'll give you an idea of where we're at this point in time. I'll share some of the analytical results with you. For those data junkies in the room, you will be disappointed, simply because I have so much data and I have no time. As Darlene mentioned, I'm also a wetland policy analyst. And as you can well imagine, I do this stuff, which I really enjoy, off the corner of my desk, whereas the wetland policy stuff, which I won't say anything about, is front and center for me. So the point is I have all these data, but I haven't had time yet to put them together. So there's no point throwing the data out at you except to show some general trends and give you an idea of what the picture looks like in the province. I'll get into some of the gaps, challenges, and current priorities. No, thank you. We already had that discussion. And then future directions, if I can manage to push off the wetland policy and get some more focus on what I really want to do. My director isn't in the room anymore, is he? So terminology, pharmaceuticals and personal care products, I think those are fairly self-evident. We're talking about drugs, and we're talking about synthetic fragrances, so deodorants, soaps, toothpastes, and pretty much anything you can think of. Organic wastewater contaminants, these are all those compounds sort of taken into one broad group that comes out end of pipe at your water treatment facility, wastewater treatment facility. Endocrine disrupting compounds. Many of these compound substances do have endocrine impacts, so they alter the internal systems of not only the human body, but organisms, let's say plants and animals. Now this emerging contaminants and contaminants of emerging concern, we tend to call them emerging contaminants, and that one really bothers me because they're not emerging. They're not new by any means. For as long as we've had wastewater, we've been introducing these sorts of things into our environment. I mean, it's self-evident, right? You have a point source, you've got end of pipe, you've got something flowing into the river. Whatever's not coming out by the treatment process is going into the ecosystem. So to call it emerging is actually quite ridiculous. What we can call it is contaminants of emerging concern. In other words, we're becoming more aware of what these compounds are, what the impacts are, simply by virtue of the fact that we can actually detect them now. Our analytical processes, our state of knowledge is at the point, state of science is at the point where we can actually detect these things at ultra trace concentrations in the environment. So I tend to go with contaminants of emerging concern. To me, it makes the most sense, but I've sort of given you the broad scape of what it is we're talking about. So what started us, or what got us going, were conversations in roughly 2002 with Al Sosiak out of our southern region office with Alberta Environment at the time, and Chris Metcalf at Trent University, who's sort of an expert in this field. They got together and they started looking at what sort of preliminary survey we could do in the province. So we did it. We went out and we analyzed for 105 compounds on several rivers and wastewater treatment sort of end of pipe studies in the province. And I actually, for whatever reason, I started with Alberta Environment in 2003. I'm the one who ended up writing the report, although I didn't have the actual pleasure of doing the fun stuff. But be that as it may, we found a bunch of different compounds in those samples. A number of them were fairly commonly detected. All the detections are very low. I mean, we're talking at the 0.01, 0.001 micrograms per liter or parts per billion. Nevertheless, we found these things, so we had reason to start a monitoring program. So in 2004, we started quarterly monitoring. 5 rivers in the province, upstream and downstream of major urban centers, with 1 reference site. The original reference site was on the upper Athabasca, so around the Hinton area. And then we kind of changed that, I guess, to recognize the difficulties of sampling for our field staff, and we moved it over onto the North Saskatchewan River around the Rocky Mountain House area. We had a huge QA/QC program, quality assurance program, that I'll speak to later. And recognizing budget realities, we changed this to semi-annual monitoring of 2 rivers last year. So we alternate between 2 sets of 2 rivers, which now are the Bowood, North Saskatchewan in 1 year, and the Old Man and the Red Deer in another. And we do two blanks and 2 sets of triplicate splits every year. One thing I should point out is these analyses are incredibly expensive, as you probably can appreciate. So we have to be fairly budget oriented when we determine the monitoring program. We've done some preliminary sediment surveys, and I think there's room for lots more work on that particular topic. And we've done a number of fish tissues as well. We did this in conjunction with Fish and Wildlife, whereby we took 18 large piscivores. I think they were actually looking for mercury concentrations in these fishes, but we had the tissues, so why not take them to the lab and have them analyzed for emerging contaminants. What we did find in the fish tissues, kind of ironically, there's not a lot of stuff found in general in terms of the drugs and the industrial surfactants, very little. What we did find was cotinine, which is a nicotine metabolite from smoking. We also found brominated flame retardants, and actually we did find many of those. Again, ultra low concentrations, but they're there. So the running joke is it's a little disconcerting that our fish are smoking, but the good news is that they won't spontaneously combust. And I don't know whoever, that's brilliant, it just fit in beautifully. So this is just an overview of where we have done regular monitoring in the province. I don't think I really need to explain it all that much. Here's the original reference site. Here's the new reference site on the North Sask, upstream, downstream Edmonton, Red Deer, Calgary. Here's a site upstream of Medicine Hat, and then 2 sites upstream and downstream of Lethbridge. One thing I should note is that Alberta Environment has a very long-standing set of monitoring stations throughout the province. It's called the Long-Term River Network. I also coordinate that. It's about 28 sites at this point in time. These are all piggybacked on top of those long-term river network sites. Obviously, that's for I guess it's for obvious reasons in terms of sampling. If we're going out to these sites anyway to do them for the long-term river network, we can grab extra samples to do the emerging contaminants monitoring. That picture I threw in, that's when I had way more hair, see? What this is an example of the early quality assurance work that we did. Those are 80-liter stock pots. So I'm thinking one of those would probably make enough soup for this entire room. They're huge stainless steel stock pots. And what we have is a submersible pump. It's only about this big. It's a fabulous little thing that puts out large volumes of water. And we would use that pump to pump the water out from under the ice into those 3 pots, sort of rotating between the 3 of them. And then subsample, again, pump goes into the pot, subsample into the amber bottles there, and then send, I think in the end, they're close to about 30, 40 4-liter bottles that are going across the country to 3 different labs. So our main lab is at Alberta Innovates in Vegreville, an outstanding lab that I'll speak to again later. We had a QA lab in Ottawa that we were using. I can't for the life of me remember who that was. And then we were using Chris Metcalf's lab in Trent until Chris told me to go to hell because he simply couldn't handle the volumes. But this is to give you an idea of the extent of QA that we actually went to ensure that our primary lab, Alberta Innovates, actually is doing a good job for us. And I have to give them kudos. They do an outstanding job. So I think that's about all I need to say about QA. You can well imagine 4-liter amber bottles traveling across the country via courier in coolers. How many of those bottles actually arrived where they were supposed to go? Well, they arrived, but they weren't necessarily in one piece. So in terms of the analyses, we look at 77 analytes at this point in time. We look at what we call acidic and neutral pharmaceuticals. That's absolutely meaningless, except in terms of the actual chemical analyses. whereby one extraction occurs under acidic conditions, the other under not so acidic conditions. Nonylphenol ethoxylates, basically industrial surfactants. Bisphenol A, which has been in the news repeatedly over the past several years. I'm sure you've all heard about it. I'll speak to it again later. Synthetic fragrances, I already mentioned. Artificial sweeteners are kind of new to the grouping that we have. I'll speak to those a bit later as well. And then, not surprisingly, hormones, which actually surprisingly are fairly uninteresting because they do seem to either biodegrade or photodegrade or something very rapidly, so we don't tend to find them. I've mentioned AITF. I'll throw another bone their way. If you do any of these sorts of analyses done, they do an outstanding job. And the other thing I find with them is if I stumble across literature and happen to find some time to read it and mention it to them before I know it, that analyte, whatever it might have been, is introduced into the suite. It's phenomenal. Or if another client happens to ask for a specific analysis, that one will enter my suite of analytes as well, which can be quite surprising when I'm actually doing my data validation and something new comes up. It's like Christmas every time. So acidic compounds. You'll recognize a lot of these. Acetylsalicylic acid is obviously aspirin. Salicylic acid is a metabolite of aspirin. They're all non-steroidal anti-inflammatory drugs. You might recognize ibuprofen, maybe naproxen, so on and so forth. Carbamazepine is used for a variety of different neurological disorders. They're mentioned there. These are anti-lipemics or anti-cholesterol drugs. The fibrate, or the fib component there in the word, does a fibrate clofibric acid. Gemfibrozil gives them away. They're also quite commonly used. DEET is an interesting one. If I don't remember to speak to it, maybe somebody can remind me later on. You all know what it is. Caffeine, whatever caffeine's in. Caffeine's everywhere. Wherever somebody takes a leak, there's bound to be caffeine. There's my little mosquito. These last ones are also very interesting. Triclosan, antibacterial, antifungal agent. Methyltriclosan is a metabolite of that. And then triclocarban. These are found all over the place. It's actually quite disturbing. They're found in, for example, plastic toys. They're found in plastic toothbrushes, dish sponges. If you've ever wondered why your dish sponge still smells fresh long after your dish rag has grown legs and walked away, it's because of these compounds. Fabrics, like antibacterial socks and stuff like that. Don't steal my tagline, whoever said that. Yeah, so. This one's really interesting, okay? Bacteria are really bad. You know, humanity hates bacteria, right? If we could get rid of all bacteria, it'd be great, except we wouldn't have any cheese or yogurt. I don't get, well, it's a marketing tool, right? Neutral compounds. Looks like the font may have shrunk on me. So codeine, most of you recognize that from Tylenol 3. Fluoxetine is Prozac. Norfluoxetine is a metabolite thereof. Prozac is really interesting in terms of surface waters in the province. We tend to find it downstream of Calgary. Not so much downstream of Edmonton. Edmonton has other drinks. We'll worry about that later. We've got a whole suite of antibiotics. We've got the lincosamides, the quinolones, the macrolides, and whatever the hell these bottom two are. Trimethoprim. I'll put a bit of an agricultural bent on this wherever I can. It's largely urban, but I have to obviously recognize the audience here. But trimethoprim in particular, I think, has veterinary applications. There's probably, I think, enrofloxacin as well. Some of these, a number of these, and this won't show up in the data, but I'll mention it later. It does have some implications in terms of surface water monitoring. Cotinine, I mentioned earlier, is the nicotine metabolite. Methamphetamine, that was just flavor of the day a couple of years ago because it was always constantly in the news, and I thought, well, I wonder if we can track these sorts of issues, right? So I mentioned it to ARC at the time, AITF, and before I knew it, I had a method for methamphetamine. Benzoyl methylagonine is also very interesting, and there's a bit of an anecdote to go with that. It's cocaine. Benzoyl egonine is a cocaine metabolite. Several years ago, there was a study in Italy whereby some researchers were looking at the Po River, and they wanted to get a good estimation of how much cocaine was being consumed within the Po River basin. So they started looking at this, and I think prior to the study, there was an estimate of about 10,000 lines of cocaine per year. And then keep in mind this is science, but based on the science, they came to the conclusion that people were using roughly 100,000 lines of cocaine per day in the Po River Valley. Now, I presented this several years ago at an Alberta Environment Conference, and there was somebody half asleep in the audience, and I made sure, when I told this story, repeatedly, I said, the Po River Valley in Italy, okay? A month later, I got a phone call from the Edmonton Journal. Yeah, I heard from somebody who was at a presentation you gave, and you said something about 10,000 lines of cocaine in the Bow River. Next. Pentoxifillin is for blood flow and circulation. And then all these sulfa drugs. The interesting point here is the sulfamethoxazole right here is generally applied in conjunction with trimethoprim. So if you get one, in most instances, you'll get the other. Too bad the audio didn't work, but anyway. Plasticizers, industrial surfactants, sweeteners, musks, and hormones. A whole grab bag of different compounds. Bisphenol A, now this one amuses me to some degree. Does anybody know what it was actually originally developed for? It was a contraceptive, an oral contraceptive that never made it to the shelves. It was replaced by the pill. But that was the intent of this thing. And for whatever reason, it was never used. It was simply shelved. And then a chemist came along and looked at it and recognized the structure and said, hey, this would make a great plasticizer. Anybody know what the first thing was that they used it for? Baby bottles. Baby bottles. Now the thing with these plasticizers is they don't actually form part of the chemical matrix. They are in the interstices between molecules. They add flexibility to the product, but they also leach over time. So obviously the older the product gets, the more likely these molecules are to leak into whatever is contained within the bottle, right? So it doesn't make a heck of a lot of sense. What amuses me about it is that we put so much effort into it to this point in time from the regulatory perspective. It's only one of who knows how many different plasticizers that are out there that perform the same function and are very likely endocrine disruptors as well. So, nonylphenol and its various ethoxylates is a bit of a pain in the butt for me because it's so pervasive, it's everywhere. So the issue is that it's also present in the analytical laboratories. So for us to actually get meaningful data out of the analyses is extremely difficult. So I'll present some of the nonylphenol data a bit later on, but kind of look at it with a bit of skepticism because it's so difficult to keep it out of samples. So these are the artificial sweeteners. There was a study that came out of Switzerland not so long ago where they were finding them, I believe, in the Lucerne area, in groundwater, in surface waters, in lakes, those sorts of things. So again, I just kind of pointed it out to AITF before I knew it. They were on my list of analytes. Now, cyclamate, 30 to 50 times as sweet as sugar. Acesulfame and aspartame are 200 times as sweet as sugar. Saccharin is 450 times as sweet as sugar. Sucralose was 600 times as sweet as sugar. Neotame is between 7,000 and 13,000 times as sweet as sugar. Now, the point being here that you need very, very little of these substances to actually achieve the levels of sweetness that you want in your product. The other thing I would mention, bisphenol A in particular, in terms of our toxicity testing, traditionally what we've done is we start at a certain level, a low level, with our test organisms, let's say a lab rat, for example. We start at a low level and then we start adding more and more and more. And with bisphenol A in particular, we found that you could pretty much drown the rat in bisphenol A before it would die. So we concluded this stuff is perfectly fine for use in human use products, right? Unfortunately, the opposite is true with many of these compounds, whereby you could actually start with a presumed low level and work your way backwards. And you'll find at some point your toxicity actually increases the lower you go. So, I mean, this is obviously a disconnect between our traditional toxicity testing and the actual effects concentrations of these compounds, and something that we need to be cognizant of. I think basically the conclusion is that at some point you basically you drown the receptors. They no longer respond. So if you have a huge amount of something, the receptor in the body simply doesn't respond to it, and you're okay. On the flip side, the smaller it gets, the lower it gets, the more receptive that receptor is to your contaminant and actually has some sort of response within your body. So that was a bit of an aside, but I just remembered that. These are all the pretty fragrances, and you'll notice they also have pretty names. Cashmeran, I mean, really? Celestalite, and these are wonderful things. How could they possibly hurt anything or anybody, right? The good thing is we don't find, with the exception of galaxolite here, we really don't find any of them. So that is, that is somewhat comforting. Again, recognizing that we have some low, minimum level of detection. Maybe they're below that level. We have to assume they are, but we don't see them in general. Those are the natural hormones that we look at. So 17-alpha-ethynylestradiol, estriol, progesterone, estradiol, and whatever. Basically, various formulations of estrogen, with the exception, obviously, of testosterone. And again, the good news here is that they do seem to biodegrade relatively rapidly, and we generally don't find them at the locations where we're sampling. And our sampling sites, 5 minutes. Have we gone 20 minutes? You're kidding me. All right, so we'll get through the results real quick. Okay, there they are, good. The point here, what I've done is I've pretty much graphed out the top 30 or so compounds that we actually do detect up against the number of samples. So the hatched bars are the number of samples that we have for each compound, and the solid bars are the percent detection. Acesulfame is a little unusual because we haven't got that many, it's an artificial sweetener, we don't have that many samples yet, so I wouldn't pay too much attention to it. DEET is odd, because analytically we're sure we're detecting DEET, but in terms of when we're detecting it and where we're detecting it, we're fairly confident that it's something else. So it looks like DEET, it acts like DEET, but it isn't DEET. So I bring that up just to kind of exemplify the difficulties that we have when we're dealing with concentrations that are as low as they are. There is some level of uncertainty, I guess. So this is one that we're still struggling with. We still haven't figured it out. Why on earth we'd be finding DEET at Cochrane in January is utterly beyond me, but maybe there's something to it. Maybe somebody's just dumping it for fun. I don't know. Most of these here are non-steroidal anti-inflammatory drugs. Right around here is where we tend to get the nonylphenols. And again, I mentioned it earlier, those hits are questionable, just considering simply how prevalent these things are. If we were to look in this room, for example, it's crawling with nonylphenols. So what those mean, I don't know. When I have some time, I hope to find out. These are the upstream sites only. And this is where the agricultural context comes into play. We tend to get, in general, it's upstream of Lethbridge that I tend to get more upstream hits than anywhere else. So and they tend to be antibiotics. So it suggests to me that there's some level of agricultural influence, veterinary application along those lines. Next. And that's pretty much reiterating that first graph. These are the downstream sites. So obviously it tells you that the biggest influence is the urban, treated wastewater effluent. I put this in to give you an idea of where the mean concentrations actually lie. So I kind of between 0.1 and 0.01 micrograms per liter. And what this reflects is this method detection limit. So most of our detections are right around that method detection limit, which is, for those that don't know, is the concentration that the laboratory can report with some level of confidence. They do occasionally report lower, but that's only when they're damn sure that it is what they think it is. But in general, that concentration is where they can say, yes, this is what we're seeing. And that for most compounds, that happens to lie right around that line. So ongoing work, so our regional offices do some stuff. EPCOR is really good in the city of Edmonton for looking at these things. City of Calgary is exemplary. I mean, they have a fairly a rigorous program. They're really interested in these sorts of things. Alberta Agriculture recently, a couple of years ago now, did a study as well. That was with some interesting results. Yeah, next. Charles Wong at the University of Alberta, the Drs. Greg Goss and Mike Milosevic at the University of Alberta as well. These guys have a really interesting facility to work with in the city of Edmonton with the Edmonton Wastewater Treatment Center of Excellence. They've actually got an inline facility that allows them to do tests with treated water. Which is actually really interesting in terms of the emerging contaminants picture and what they can do with that. Lee Jackson and Hamid Habibi at the University of Calgary. These guys actually found skewed sex ratios in the South Saskatchewan River, where we had some dace populations where 90% of the population was female. Alice Hontella at the University of Lethbridge. Knowledge gap, fate and persistence, the big picture. We don't understand the big picture. We're simply talking about, too many compounds. I've got 77 here. We're talking on the order of hundreds to thousands of different compounds. Individually, they may not have much impact, but together, we don't really know what the implications are. And that's what I'm getting at, known pharmacology versus the unknown environmental behavior. So the planned effect in your body versus, and I'm using drugs as the example, the planned effect versus the unknown effect in the environment. Bioaccumulation, biomagnification, synergistic effects, where one compound plus one compound equals 3 times the effect. Additive effects, whereby 1 plus 1 is actually just the two together, 2. Antagonistic effects, where one will actually cancel out the other. What are the human health implications? I'm not allowed to look at those because I work for environment. Breakdown products, metabolites. So you've got your stereoisomers and enantiomers, where the compound is the same, but it's sort of a mirror image and actually has a totally different effect. And then there's the challenges around communication. I only get 20 minutes to speak, so I can't properly communicate with you guys. But coordinating, the same thing that everybody else struggles with, is coordination between the different agencies to make sure that we're covering the whole picture and that we're not all duplicating efforts. Why are we doing this? The big so what? Who cares? That's what I get from the researchers all the time. Why are you worrying about individual compounds? We don't care about those. We want the whole, they take the whole suite of compounds at the Treatment Center of Excellence, and they look at the effect of this water on the goldfish. Well, that's great. You're doing your part on the research end. I'm doing my part on the, I guess, more specific compound-oriented end. Paucity of data and difficulty of deriving those data. I said it's prohibitively expensive. Our program is actually the Cadillac for North America in general. I mean, I have these conversations with others, and they're aghast at what we've been able to accomplish in recent history. Obviously, that's going downhill in the past few years, but we're trying to maintain what we've got. So we want to, there you go, maintain a monitoring program, a network, so that we're all communicating with each other. I'm faltering on that front. We want to look at some synoptic surveys, so sort of start to end in terms of what happens with these compounds. Biomonitoring, effects monitoring, blah, blah. Polybrominated diphenyl ethers, perfluorinated compounds. These are the 3M and the, whatever else the other one is, right there, DuPont. 3M and DuPont products, these have endocrine disrupting properties as well, and additional method and capacity development. Nanomaterials, anybody know what that is?
The buckyball.
A buckyball. Buckminster Fullerene, I just really liked it because it's been easily amused, obviously. Quick acknowledgements, our surface water team, our outstanding field staff without whom this would not be possible. I do try to get out in the field every now and then and help them when I'm asking them to do these huge QA projects because I feel guilty. But without them, it wouldn't be possible. I've mentioned Alberta Innovates multiple times. Alberta Agriculture has been a good partner on this. And then our Southern Region staff. And then various universities. I mean, this is a fairly tight-knit community. There's reasonably good communication between everybody. And it's a lot of fun. I get pretty excited about it. And we're like at 28 minutes, so there's probably time for one question.
Yes. Yeah. Does anyone have a question, Thorsten?
Go ahead.
I saw some work a couple of years ago on pesticide monitoring of water. Are you involved with that as well?
I mentioned our long-term river network, and we do, as part of that, we actually do sort of May through September monitoring of pesticides in all the major rivers in the province.
So you have, do you expect another report coming out in near future, or?
I don't expect anything anymore. There is the potential, and I would certainly hope that something will come in the near future.
It'd be interesting to see the past and then what it is currently, you know, some of the changes that have happened.
Yeah, as part of that regulatory change, or that policy change, we actually did enhance that monitoring program for for pesticides in the province. And yes, we have to report on that, and I expect that'll be forthcoming in the next couple of years. One more?
Anyone
Yeah,
else? Okay.
You had a slide that was showing differential or differing amounts of prescription drugs between the downstream sampling locations from different Alberta cities.
Yeah.
And I was wondering if that difference could be more so due to differences in river conditions, microbial communities, macroflora, rather than just necessarily what doctors are prescribing. In other words, something that might uniquely affect the fate and transport.
Potentially. I mean, it could also be just, you know, a temperature thing, or, you know, any number of conditions that could contribute to that. My thinking is it's probably more likely demographics and prescription preferences between the physicians, or between the groups of physicians, but there's also potential for the microbial community and any number of different environmental factors. So I would never definitively assign that to any particular influence, but I think there's potential for any number of different contributors.
And just a comment, sorry, on the bisphenol A, part of it was, it was tremendously, it was a fought over issue very heavily amongst academics in the States that got into the political arena. That's partly why it got such big focus.
Yeah.
But also it was found that it was equipotent as estrogen for certain endpoints, so it was operational on the picogram per liter level.
Yeah. Yeah. And a lot of the research is, I guess that's what supported that response. But then my response to that is, okay, fine, you pinpointed bisphenol A, but what about the entire suite of other compounds that we use, right? This is only one in that picture.
Yeah.
But
Just less potent is all.
Yeah.
All right, and with that, please join me in thanking Thorsten.